Tokenizers encode and decode. They take an input and encode it into tokens IDs. And they take an input ID, which is a set or an array of IDs, and return a text. So the next two functions that we will be building on our tokenizer are the encoding function and the decoding function. So let's get started with the encoding function. For this function, we are going to use the following parameters. The text, of course, this is the input that we're going to be encoding, converted into IDs. The max length, this will tell us the maximum length of the sequence that we are encoding. Truncation, whether we want the encoder to truncate or not. Sometimes we want it to truncate when it goes beyond a certain size. And return tensors. And this is going to be very useful when we are building the trainer loop for the model. Because when we are training, we want these IDs to be tensors, not just a simple list of numbers. The first step is to take the text and tokenize it as we saw above and convert it into tokens. Now we have the words, each one separated from the other in an array. We're going to pass this array to our word2 IDX helper function, and we are going to convert it into numbers, each one by one. As we had defined, we will prepend and append special tokens to every input. So we are appending here into the encoded token the start token and the end token. We're putting them together and we're building the complete encoded function. If truncation is equal to true, now we're going to truncate if the length of the encoded tokens are larger than the max length. And in this case, we basically cut it at that max length and make sure that we continue appending the end token if it doesn't exist. And now we return the encoded tokens. If we decided that we wanted to return a tensor, we basically transform the encoded list into a tensor, and that's what we return. So this is the encoding function. Let's test it now. First, let's execute this cell, and now let's use it with this nice sentence. Red roses mean love. Notice that I am using a period here. Let's see what happens. As you can see, we're seeing the 9088, which is the start token as defined here, followed by the tokens of the words red roses mean love. Red roses mean love. And then period, and then the end of sentence, which is 9089. 9089, end of sentence. Now, check this out. We have two 9090s. If we go back, we can see that 9090 means unknown. That means that for our vocabulary, the word roses and the symbol period are unknown, and that's why it injected the unknown there. Remember, we excluded that voluntarily to make this exercise easy. I am surprised that the word roses is not used in the Sherlock Holmes. Now that we have created the encoding function, we will create the decode function, which goes the other way around. We pass it a list of indices and convert it into words. There is an additional special parameter here called skip special tokens equals false by default. This parameter is not needed right now. It would be needed in the generation of the data of the model when we build it, and it will basically help us skip or not skip the special tokens in the output of the decode function. So the first thing that we have to do is make sure that this is a list. Many times we will pass a tensor. In fact, when we are doing the training and the generation, we will be passing tensors here. So what we do here is we convert it into a list of integers. If this skip special tokens is true, we will exclude the special tokens from the generation. If not, we will just let them be. Now we're going to take the indices, use the helper function IDX to word, run through each one of the indices that were passed, and add them to tokens. Here we have the special consideration for the special tokens, whether they should be excluded or not. Before returning, we are joining everything in a single string and we are returning the text. Let's run this. And let's take the encoded text that we have here and return it into text again. Here you are. So in this case, we are getting S for this start, unknowns, and the end of sentence. If I were to skip these special tokens and return only the text, then this is where I would use the skip special tokens equals true. We run this again, and we only return red, mean, love, which are the only words that are included in our vocabulary. Very good. So now we have the very basic, the essential functions of a simple tokenizer. But to make it a little bit more similar to Hugging Face, let's add a couple of more functions. One is going to be convert IDs to tokens and convert tokens to IDs. If we check out the famous tokenizers, you will see that we had these functions here, convert IDs to tokens, and they also have the convert tokens to IDs. So let's add them, and this is a very simple function. In the convert IDs to tokens, basically we receive the token IDs and we use this helper function to return the tokens, and the convert tokens to IDs, we do it the other way around. Receive some tokens, we pass it through the word to IDX helper function and return the token IDs. And with that, we will be very similar to what Hugging Face Tokenizer is doing. There are many other functions that the Hugging Face Tokenizer uses and that we're not implementing here. The purpose of learning how the tokenizer works can be achieved by looking at what we have done so far. But you are encouraged to go and explore more the tokenizer of Hugging Face to learn much more about what a production-grade tokenizer entails. Again, now that we have everything together, let's put everything together on the Simple class.